In the last notes, we looked at arithmetic sequences. We'll be looking at geometric sequences today. Learning target is that you can find something called a common ratio on these, and that you're also able to find the nth term of a geometric sequence. So we talked about sequences before. It's a list of numbers in a particular order. We're going to be looking at this type of sequence today, the Fibonacci sequence. It's known as a recursive sequence. We'll come back to that one in a little bit. We just, like we said, looked at arithmetic ones. Today we're going to be focusing on geometric and this recursive one. Just to recall, remember, geometric, we're looking for the common ratio. What's the pattern here happening? In this one, it was times 2. So our common ratio that we're going to use R for is 2. All right, so the first problem wants us to find the next 3 terms of this geometric sequence. Okay, some of you might be able to just look at this and see what the pattern is. It looks like we're timesing by 7 each time, going from one term to the next. If you're not sure what the ratio is, you can always do it by taking the second term and dividing by the first term. So if you take 21 divided by 3, you get 7. So what you would do is go on your calculator, especially with these ones because they get a little bigger than some of the arithmetic ones, and just keep multiplying. So if you hit times 7, looks like the next term's 1029. Go on the calculator again, hit times 7 again, and you can just keep going to fill out this pattern. So the next one's 7,209. If you times by 7 again, you'll get 50,421. So once you get the pattern established, then just keep multiplying by that. All right, number 2, what's the common ratio R of this geometric sequence? Okay, now looks like you can kind of see it's dividing by 2, but when you're doing a common ratio, you need to figure out what's it being multiplied by. Okay, so again, you can always find it by taking the second term divided by the first term. So what's 6 divided by 12? Looks like here the common ratio, if we simplify that, is 1/2 or 0.5. So when you're dividing, it actually turns into like a fraction as your ratio. All right, if you are given some information about a geometric sequence, you can find any term using this formula right here. So just like with arithmetic, this is the nth or last term that you're looking for. This is the first term. R is your common ratio, and then n is the number of terms that you're looking for. So let's look at an example problem here. This one says find the 8th term. Okay, so if we want to find the 8th term, that means n is going to be 8 of a geometric sequence for which the first term is -3 and r is -2. So putting it into this equation here, we can find it. A sub 8 is going to be the first term, -3. Okay, r is -2. And then our exponent here is n minus 1. So this would be 8 minus 1. So this is going to be -3. 8 minus 1 is 7. Now be careful here. Do not do this as your next step and go, okay, -3 times -2 is 6, and then do 6 to the 7th power. No. Remember, order of operations says after parentheses, you need to do exponents next. So what we got to figure out is what's -2 to the 7th power. -2, parentheses, -2 to the 7th power is -128. So we got -3 times -128. Now we can multiply those together and get our answer, which comes out to be 384. Okay, or once you get to this step 2, you could just put it in your calculator, and that would give you the answer. If you do -3, parentheses, -2, close the parentheses up to the 7th power, 384. Okay, so that's one way you can do it. Now, like we mentioned with the arithmetic sequences, if you don't want to remember another formula, This is very similar to something else we did back in Unit 11 here. This equation, if we were to just change the first term to the 0 term, then this n minus 1, we would be taking the minus 1 part off, and it would just look like this. A sub n equals a sub 0 times r to the n power. That is the exact same equation we worked with exponentials. You just saw it like this. A times b to the x. It's the same equation. It's an exponential equation. Okay, so this would be your starting amount, a sub 0 or a. B is your multiplier, x is the number of times you're doing it. So we could also do the same problem using that equation. If you were going to do it with that equation, y equals a sub 0 times r to the n, then you just got to figure out what that a sub 0 is going to be. R is still going to be negative 2, n is going to be 8. You got to figure out what a sub 0 is going to be. You can do that using these. Okay, if the first term is negative 3 and r is negative 2, you can get a sub 0 by dividing. So if you take your first term and divide by r, that'll tell you what a sub 0 would have been. 1.5, 1.5. So if you put this in your calculator, it should give you the exact same answer. So if we do 1.5, negative 2 is our multiplier to the power of 8, 384. So just like with arithmetic, you got your choice. If you want to use this formula, awesome, do it. If you just remember your exponential one from Unit 10, even better. Okay. Let's look at this one. Number 4, write an equation for the nth term of this geometric sequence. Okay, so again, you could use this formula that was given. If they want the nth term, that means we're going to try to find n. We know our first term here and our multiplier by looking at the pattern here. So it looks like times 4 each time. So that's telling us r is 4. Our first term of that sequence is 3. So if you put that into the equation up there, a sub n equals our first term 3. Our multiplier is 4 to the n minus 1 power. And that would be one way to write that equation. Another way you could do it is using that y equals a sub 0 r to the n equation. The only thing you'd have to find out is what is a sub 0. So a sub 0 would be our first term divided by r, which is 4. So it looks like 3/4. So you could also write it as 3/4. R is still 4 to the n power. This would also be a equation that would work. Both of these are saying the same thing. It's just written a little bit differently. How you would know that they were the same would be to kind of simplify this equation over here. If you have two things in our exponent here being subtracted, that'd be the same as this times 4 to the n times 4 to the negative first power. And then 4 to the negative first power is the same as 1/4 if you move it down to the denominator. If you multiply 1/4 and 3, you get the same equation as we have over here. So they are equal. Let's try another one. Number 5, find a sub 9 if a sub 4 equals 16 and r equals 4. Okay, I'm going to use that exponential equation because I like that one better. Okay, so what is r? Well, we know r. They tell us right here. R is 4. What we don't know, though, is what is the first term. They do tell us the 16th term, or I'm sorry, the fourth term is 16, and they want us to find the ninth term. Well, if you're given a problem like this, it doesn't really matter what you call your first term. We could just say, let's, instead of having this be the fourth term, let's just call this one the first term. Let's say that one is 16. Well, what term in the sequence would we be finding then? Well, if we make a sub 4 our zero term, that means we took 4 and minus 4 from that to make it a sub 0. So if we did minus 4 off of this, let's figure out what term in the sequence we would be finding then. 9 minus 4, we would be finding basically a sub 5, meaning that n in this problem is going to be 5. So if we put that information over here, we can now find it. So a sub, and I'm going to call this 9 even though we're not finding it. Or even we're finding it even though we're going to be putting different numbers in here. Our zero term would be 16. Our ratio is 4. And then n would be 5 terms later to bring us to there. So 5. So if we solve that out, that should tell us what a sub 9 is. So a sub 9 would be, and here's where you can use calculator, 16 times our ratio of 4 to the 5th power. Looks like, and these ones get quite big, 16,384. So if they don't tell you the zero term, just take whatever term they give you and make it the zero term and just adjust which one in the series you'd be finding then. All right, number 6. A family of mice have found a 50-pound sack of grain. 1/5 of its weight in grain is disappearing every week. How much of the grain will be left after 3 weeks? Okay, so let's see what we have here. 50-pound sack of grain. That's what it is originally. So that would be our a sub 0, would be 50. That's another reason why it's nice, especially with these word problems, if you use the exponential equation to do this. All right, how much of the grain will be left after 3 weeks? Looks like in this problem that's telling us n is going to equal 3. Okay, the only thing left to figure out is what is r. Now, this is the tricky part about this problem. It says 1/5 of its grain, weight in grain will be disappearing each week. So does that mean then our r is 1/5? No. And the reason we don't want to use 1/5 is because 1/5 is what's disappearing. When we make a list of things, we want to know, okay, if 1/5 of this, let's divide this into 5. If 1/5 of this disappears each week, well, what we're looking for is not what's disappearing. We want to know how much of this grain is left over. And what would be left over would be 1, 2, 3, 4/5. So our ratio in this one is what's left over, 4/5. 4/5 each time is going to be left. Because we want to know how much grain will be left. Not what's being removed, what's being left after 3 weeks. So now if we put this into our little equation here, a sub 0 equals r to the n power, we can find it out. The original value is 50, r is 4/5, and n would be 3. So if you put that in your calculator, we can find how much grain is going to be left. 50 parentheses 4 divided by 5 to the power of 3. And it looks like there would be 25.6 pounds of grain remaining. All right, number 7. Each year, Ms. Meyer's teacher retirement increases by 15%. If she has $27,000 in her retirement now, how much will she have in the account after 7 years? All right, so again, let's find out what we know. This is her original amount, 0. That's what she has to start with. How much will she have in the account after 7 years? Number of years is 7. what is her R going to be here? Now this time it was given by a percentage, and it's increasing by that percentage. So again, we don't want to find what's the increase, we want to know the total amount. So just like you did in that exponential unit, we're starting with 100% of her salary. We're adding 15% to her salary. Now we're going to be finding what is 115% of her salary. But we can't have R be a percentage. We need to change that to a decimal. So if you move the decimal point over 2 times, that means our R is going to be 1.15. Some of you, when you did this, also did it by taking 1, which is like 100. 1 is just 100 as a decimal, plus, and then you changed the percentage here to a decimal, be 0.15, and you get the same thing, 1.15. So that would be our R. Now if we put that into the equation, we should be able to solve this one. A sub 0 times R to the n. We got 27,000 times 1.15 to the power of 7. So put that in your calculator and you got the answer. 27,000, 1.15. Oop, forgot a 1 in there, to the power of 7. And so it looks like her salary in that year is going to be $71,820.54. All right, that's geometric. The other thing we're going to look at today is a recursive formula. Recursive formulas are where each term is generated from one or more of the previous terms. It's not a set pattern like we've looked at with the other ones. So in the arithmetic one, we talked about this Fibonacci sequence. The pattern is that you get the next term in the sequence by adding up the previous 2. So if you take 1 plus 2, you get 3. If you take 2 plus 3, you get 5. If you take 3 plus 5, you get 8. If you take 5 plus 8, you get 13, etc. So how we would write that out is by saying in this, a sub 1 is 1, a sub 2 is also 1, a sub 3 is 2, and so on. If you want to find, say, this third term, a sub 3 equals a sub 2 plus a sub 1. Well, how would we write that as a general equation? What if we want to find any term in the sequence? Well, a sub n would be the term before that one plus the one 2 before that. So we would write this as a sub n minus 1, that'd be the term right before n, plus a sub n minus 2, which would be 2 terms prior to that one. So this is the recursive formula for the Fibonacci sequence. All right, let's look at number 8. This is another recursive formula here, right here. So they want us to solve out what that is going to be. All right, well, they tell us the first term here is 4. So we know a sub 1 equals 4. What's a sub 2 going to be? So let's come over to our recursive formula here. And in place of the n, let's put 2. That means anywhere there's an n in this equation, we also want to put a 2. So we also want to put 2 there. But this is 2 minus 1. Okay, 2 minus 1 we know is the same as 1. So the second term in the sequence is going to be 3 times the first term. That's what a sub 1 is here. The first term minus 2. Well, we know what a sub 1 is. A sub 1 is 4. So let's substitute that value in, and then we can find out what a sub 2 is. A sub 2 is going to be 12 minus 2, or 10. So we know the second term in the sequence is 10. Now you just repeat that, keep repeating that, and you can find all the other terms. So let's keep going here and find the other ones. Let's find a sub 3. So if we want to find a sub 3, it's going to be 3 times the term before, a sub 2 minus 2. Well, we know from what we just did that the second term in this sequence is 10. So a sub 3 would be 30 minus 2, or 28. So this is the next term in the sequence. If we want to find a sub 4, it's going to be 3 times the term before, which is a sub 3 minus 2. We know the term we just found was 28, so times that by 3 and minus 2, and that term ends up being 82. So that would be the next one. Why don't you pause the video, see if you can find the 5th term in this sequence and see what you get. All right, let's check out and see how you did here. The 5th term in this sequence is going to be 3 times the 4th term minus 2. The 4th term is 82. So if you do 3 times 82 and subtract 2, you should have gotten 244. That would be the 5th term in this sequence. Let's try one more of these recursive ones. So the number 9 one, this should be number 9, wants us to find this. And they tell us that the first term here is negative 3. What's 2, 3, 4, 5 terms in this sequence? So start out the same way. If we want to find the second term, let's put 2 in for any n's. Now notice there's also an n over here. So what's that going to look like when we put 2 in everywhere? A sub 2 would equal a sub 2 minus 1 plus 2. Well, 2 minus 1 simplifies to 1. Well, a sub 1 is the first term. We know what the first term is. We can look right here and substitute that value in. So a sub 2 is going to be negative 3 plus 2, which is equal to negative 1. So the next term in our sequence is negative 1. Now we repeat it. Let's find a sub 3. So anywhere we see an n, let's put 3. This would be 3 minus 1 plus 3. 3 minus 1 is going to be 2, so that's the previous term plus 3. The previous term is worth negative 1, so substituting that in, the next term is 2. Okay, we should now be able to find the next one. Kind of repeat the same process. What's a sub 4? So this would be 4 minus 1 plus, again, we're substituting in for n. That would be 4, but that's not a subscript. That's the actual number we're substituting in. Well, a sub 4 then is going to be 4 minus 1 is 3 plus 4. A sub 3 is just the value we've just found. That's 2. So it looks like the 4th term is 6. Why don't you again pause the video, see if you can find the 5th term in this sequence. All right, let's see what you came up with. A sub 5 on this one would be the 4th term plus, and then because we put 5 in for n, it'd be plus 5. And the 4th term we just had was 6. Oh, sorry, this should be a 5. So the 5th term in the sequence is 11. So if you got 11, nice job. Now notice with these, there's a lot of recursive ones, you can't really see the pattern just by looking at it. Because here, this is going up 2, then it's going up 3, then it's going up 4. Well, actually, maybe we can see the pattern in this one. Looks like it's just adding 1 more each time. So sometimes recursive formulas, you can find the pattern kind of easy. In this one, let's see if we can find it. This would be plus 6, plus 8. Ooh, this one doesn't, or sorry, plus 18. This one's a little bit harder because now if we do that one, we got 82 minus 28. That would be plus 54. A little bit harder to see the pattern Sometimes you can figure it out, sometimes you can't. That's why recursive formulas get to be a little bit more difficult. But you should be, if given the formula, should be able to figure out any term on there. All right, why don't you try some of the practice ones on your own.